Okay, so let's get started. Thank you everybody for joining me for my talk today, as well as all the other talks today. I am going to talk about RaspIOT, personalizing the Internet of Things with a Raspberry Pi. So to get us started, I would like to quickly outline what the IoT is and what a Raspberry Pi is, because not everybody in the audience might know. What can you do with these things? And then, of course, what I want to do with these things. I have a quick demo prepared for everybody, and then I would like to talk about the technologies I used, the challenges I faced, and the learnings I made throughout the way, and then a very small, very quick conclusion. Okay, let's get started. Jan already put us in the right direction for all of this, but I want to quickly mention what is the IoT. As you saw in my title, it stands for the Internet of Things, which describes all kinds of appliances or devices that share information over the internet and can sometimes be accessed over the internet or just broadcast the information through the internet. Examples for this include computers, obviously, mobile phones also, obviously, cars nowadays can do this, and all other kinds of smart home devices. We already heard Julie earlier today talking about smart devices, and Jan brought up the example of a smart toaster. There's many more, of course. One that is very popular these days, I have one myself, I have to say, is a Roomba. So a vacuum cleaner that you can either remote control or that you can just start through the internet. And that's just one of many examples of things you could use, of things that belong to the Internet of Things, that have an Internet of Things. Next up is, of course, what is a Raspberry Pi? A Raspberry Pi is, in essence, a very small computer, a so-called single board computer. They have been produced since 2012, and it's currently in its fourth generation, has its own Linux-based operating system, and it costs around 7,000 yen, which is around $50, 40 euros ish. This is the logo that you might have seen already, and this is how the tiny computer looks. It comes in this wonderful, very small box, as you can see, and it is still a very powerful machine because hardware has made a big jump in recent history, and we can build smaller and smaller devices that are still very powerful. Now, what can you do with this device? First of all, you can use it as a fully fledged workstation. This picture here shows the Raspberry Pi 400 in the keyboard. This means the entire computer is built into this keyboard. And I have one of these myself too. So I own two Raspberry Pi Pis. What can you do with it outside of just using it as a normal personal computer to work? A graduate of Code Chrysalis named Keisuke Mori has used a Raspberry Pi to build his own Google Home Assistant. So he can talk to the Google Home system. And please check out the link below to his talk that he gave a while ago, where he goes through this and he sets this up live on stage, and it actually works live on stage. And it's a really cool demo that he has there. Another thing you can do with it, and this is what got me interested in the Raspberry Pi, is you can actually program hardware with this directly through its GPIO, its general purpose input and output system. Oops. You can use these pins that are on the single board and program these directly. You can directly send energy through these ports, connect them to cables, and then, for example, turn on an LED. And you can see this on the picture on the right, where it uses an extension cord and a so-called breadboard, which is this, where you can just connect all the wires itself. You can also do this with the other model that I've shown, where it would plug into here. And this is really interesting because I myself didn't have any experience programming hardware before, and it's a really interesting process and a really interesting task to take up. What can you do with this? Well, I have another talk from a CC grad for you, which is called JavaScript for IoT, A Tale of Johnny 5 and a Tesla 2. A Tesla 2 is a very, very similar product to the Raspberry Pi. You can program this and program the hardware using JavaScript. And I would especially like you to check out this talk because it's by Stefano, who was actually my teacher in the CC Foundations program. So Stefano, you got me started on all of this in case you're watching this. My goal is now to combine all of the above. I want to use JavaScript to give remote access to as many of the Raspberry Pi features as possible and do all of this remotely. I want to use the small footprint in size, energy use, and cost, the GPIO accessibility, the advanced camera functions, and the endless customizability of this device. It's a very hard word to say. And then pick and choose whatever aspects I want, really. So my build for this is as follows. The standard model Raspberry Pi 4 computer with 4 GB of RAM and 32 GB micro SD card. A breadboard with a GPIO extension shield is what it's called, the Raspberry Pi camera, which is a 1080p 5 megapixel camera, a very, very small LCD screen that I'll show in a little while, and the FreeNAV Ultimate starter kit for the Raspberry Pi is what I'm also using. This kit costs around 4,000 yen ish, and it gives you a lot of different sensors and cables and everything, and the breadboard itself, everything, so you can set it up for yourself. And no monitor is necessary for this setup, so you can control and connect to the Raspberry Pi through your Wi-Fi, for example, to start setting up and start the programming process. And this is how it looks. I know it's not the most fanciest battle station, it's not the most fanciest gaming setup. It is, but this is of course not for gaming. We don't need super powerful things. We need something that we can control remotely. So to go through this, on the right here you can see the Raspberry Pi itself in a very simple case with a very simple fan, just so that it doesn't overheat. Then you can see a standard IDE cable. You might be used for these if you used to build your own computers, because old hard drives use this cable all the time, and I still have a lot lying around in different places. This connects into the GPIO through this extension shield, and then on the GPIO I can connect all the cables to program the LED here and this LCD screen. And also there's a small camera shown. So let's see this in action. I have built a very simple front end in React with JavaScript for this that is currently hosted on Heroku. So this is hosted on the internet. And through the internet, I'm controlling the Raspberry Pi, which is currently right here. I know my camera is too small. You are not able to see this properly. Don't worry, I just want to point to it. Even though both my computer here and the Raspberry Pi are, of course, in my network, I am actually controlling this through the internet. So if you knew the link to this website, you could also control this. Okay, what can we actually do with this? First, simply, we can take a picture of what the Raspberry Pi camera is currently looking at. And you can see this here. You can't see much, but that is on purpose. You can only currently see the GPIO from the side, and you can see everything on it. Next step I can do is I can turn the small LED on and capture another picture. And you can see the LED lights up. Very, very simple example so far. Now I'll move the camera a tiny bit so it focuses on something else, because I would like it to look at the tiny LCD screen that I have. And you can see there's nothing there. And then I can set up hello CC19 to say CC19 to say a quick hello to all of my cohort mates that are watching this currently, hopefully. And as you can see, when I capture another image, this message shows up. Now again, this is all controlled through the internet. So I don't have to set this messages myself. Somebody else could set them for me if I gave the link to somebody. I've done this in previous presentations about this with my cohort mates, and many people had a lot of fun sending me messages. I will not do this right at the moment. I'm very sorry, but I cannot control what they would put in. Instead, what I want to show off is I am planning to do next, so to speak. Because the next logical step from here is, of course, not just pictures, but live streaming videos. And that comes, unfortunately, with a problem. I have a test video set up that is currently stored on the Raspberry Pi that I can now load in through the internet. And this is my assistant, Shotakun. So accessing videos from the Raspberry Pi is no problem. The thing is that this video is in the MP4 format, and that format browsers can understand natively. Unfortunately, the video codec that this camera uses is a different codec, and browsers cannot natively understand this codec, so to speak. So to do this, I would have to convert it first, and I'm not quite there yet. I now know, I just found how to do this. So after this talk, I'll probably get right back to work and set it up after I've seen all the other presentations, of course. Instead, I've set up a quick test stream anyways, which just takes a picture every 5 seconds. So if I put my hand in between here, you can see after 5 seconds that my hand shows up and then disappears again. Okay, that's all I wanted to show, just to give an example what is possible with this machine. So I want to give then a small side note. You've already, if you've been following us through the whole day, you've already heard a talk given by my cohort mate and friend Michael, who has talked a lot about internet security. And if you're watching this later on YouTube, go find his video because he gives a lot more detail, and it's a really good presentation that he gave. For everybody just watching, just tuning in right now, I'd still like to give a very quick reminder how important this is, because I am opening up this Raspberry Pi to the internet, and that always comes with risks. The importance of online security cannot be overstated for these kind of things. Whenever you open yourself up to the internet, it is possible that somebody could attack you. And this has even happened to professionally made IoT devices. For example, this is an LG vacuum cleaner, and people have figured out a way to go through to somehow access the camera that this vacuum cleaner uses. And they were able to see what the vacuum cleaner was looking at while he was cleaning. And of course, you don't want to have that in your home. So please be careful around these topics. Okay, now with that serious note out of the way, let's talk about what the technologies are that I used. First of all, on the front end, as I said, React, Axios, JavaScript, React to build the simple website, and Axios to handle the HTTP requests. On the back end, there's a little more action happening, of course. There's first the Raspberry Pi OS that I wanted to mention here because it's a Linux-based system and a little out of the ordinary. It's still easy to use, but something to keep in mind. Next up is Node.js and the Express server to set up the server in the background and actually make the system work. Cause was also involved in this. And then JS FM MPG is the converter that I'm hopefully going to use later this weekend to set up the streaming. For the GPIO itself, I used quite a few different repositories and libraries that I found on GitHub. First on-off to work with a general GPIO interface and trigger the LEDs. Liquid Crystal is there to handle the LCD screen. And the Pi Camera Connect is, of course, obvious to access the Raspberry Pi camera. Alternatively, I could have used the Johnny 5 IO library that Stefano talked about in his talk to access all of these things. I chose not to do this because just for my own learning, I found it more important to go really step by step. So first step, just make an LED turn on. Second step, set up the LCD screen, and so on and so forth. And then for deployment, I used Heroku, which we are all very familiar with because it's a very great service to set up and deploy websites quickly and still change things very quickly. And then I used a service called NGRock that helps with connecting my Raspberry Pi, not connecting it to the internet, but to make it accessible through the internet. And I want to give both these services a shout out because they're both great services that you can use right away. Okay, the challenges I faced in this are pretty much what you would imagine. First, the setup process is not easy. Setting up the Raspberry Pi itself is easy, and it comes fully prepared. You can basically turn it on, start it, connect it to the internet, no problem. What is not so easy is, of course, the setup for the GPIO and the breadboard. And I didn't have any experience with this previously. And the last time I had to think about resistances and transistors and energy flow was back in high school. So that was quite the task for me, but it's a really enjoyable task and something that is good to learn and remind yourself of that it exists. The second point is the cable length, just because all of these things are, of course, small. That's the whole idea. The Raspberry Pi is supposed to be small. So the cable length that you get provided in these starter kits is also pretty low, which makes setting this up a little finicky, but not too bad, actually. The real problem is it's hard for me to show this off. Now, of course, the camera window is pretty small, so it wouldn't work that greatly anyway, but still everything needed to be very close together. As I've already mentioned, browsers cannot interpret the codec, it's called H.264, directly, as far as I understand the situation at least. I could not make it work right away. Next point is different hardware means different versions. Is always something to keep in mind. I, of course, mainly use Windows on my computer right here. And on the Raspberry Pi itself, I had to update, for example, Node.js. And because Node.js is a very specialized program that's very deep in the system itself, this is not quite an easy process. And then the last point is getting used to the OS. As I've said, this might really not apply to you. It's a Linux-based system, and it's been a while since I've used my last Linux system, so just getting used to it again took me a little while. On the other hand, though, I've had a lot of great learnings during this whole process. The first thing is, the first solution you find is not always the best. I could have used the Johnny5.io library, and it can basically do all the things that I'm also doing, but I really wanted to go step by step and just understand each step and learn each step by itself. At the same time, there is a universe of resources out there. The amount of work people put into this tiny device on the internet, on GitHub and on YouTube and on their own websites is amazing. The website for the Raspberry Pi itself is also a great resource to use, and there's just a lot out there that you can use and look into and get really lost in if you have time and fun with this. And even the smallest GitHub repository can have amazing functionality. For example, these are the stats for, I think this is for the Liquid Crystal repository. And you can see that it's not many people that have forked this or started this or watched this, but still it's really greatly laid out. The README was very good, the documentation was very good, and it just worked very well. And altogether, I can just say that the Raspberry Pi offers great accessible functionality, and it's very easy to get your own idea going with this. So, what are my future plans for this? A lot. The idea is, of course, to find and combine further projects to something that I really want to use. As you might imagine, I've brought it up a few times now, is streaming is where I really want to take this. I found somebody who built an entire camera just with a Raspberry Pi and the tiny camera into its own box and use it for live streaming YouTube directly. It's not shown here, but he has a small panel on the background where he can just start it right away. And the second thing I want to combine this with is not quite as obvious, because this is a step motor. So it's a very small motor that you can control through the breadboard and through the Raspberry Pi. So of course, and obviously, I want to set up live streaming on my little front-end website that I built, and stick the camera on top of the step monitor so I can move the camera around while it's streaming. And I will, as I said, get started on this probably later today or tomorrow. And that is my conclusion to all of this. You can really use this to make something that fits your needs. And you don't have to focus on what's available on the market. Jan talked about the Apple IoT system, and I'm using this myself too, but you can build something yourself out of all of this. It doesn't matter if you like Apple or Android or what you want to use, you can just make your own and make exactly what you want. And it's a really, really great, really rewarding process. I would like to encourage all of you to tinker away. Thank you all for listening. You can find me on Twitter and on GitHub at the link here. And usually at this point, we share the deployed application. This, of course, doesn't make sense because you don't want to control the lights and the LCD screen in my home. You want to build it yourself. So please feel free to look at my project repository. I've written a README that hopefully explains my thinking and how I got this started. Clone it. Please get involved. I would really, really like to see what other things people come up using this.